All right, today we're talking about two lessons, okay? So don't be scared, it's just a bunch of words, you know, it's not gonna be a big deal. So first we're gonna talk about lesson 10.2, find arc measures. First, make sure you write down the definition of a central angle. It is the angle whose vertex is the center of the circle. If I look here, this right here is the vertex, right? That's where the angle bends. So this is a central angle. How we would write that, remember we use three letters, so angle APB, or we could say this is angle BPA. Okay, next, number 2, a minor arc is the part of the circle and measures less than 180 degrees. So the arc here, if we look at example or number 1 from the central angle, this arc AB is the same as the central angle. So that is also 30 degrees, okay? So if I would notate a minor arc, I just use the two letters, and then I do like kind of like a rainbow over top. So arc AB is equal to 30 degrees. We need another second to copy that down, but just make sure that you know a minor arc is less than 180. Okay, that makes it minor. A major arc is the part of the circle that measures between 180 degrees and 360 degrees. So a major arc would be all the rest of this, right? We all know that a circle is 360. Well, if we subtract what we already know, we know that this part is 30. Then the major arc would be 330 degrees, which is between 180 and 360. So when we name a major arc, because it's so major, we're going to use three letters. It doesn't matter which way you go. I can say ACB with my little arc over the top is equal to 330 degrees, or I can say arc BCA is equal to 330 degrees. Oh. So we're just naming the blue arc for this major arc. Okay. All right, number 4, a semicircle. Well, I mean, you should be able to figure that out. Semicircle is like half of a circle. Is an arc whose endpoints are endpoints of the diameter. So I have a semicircle here. See, the endpoints are my diameter AB. I also have a semicircle here on the other side. And remember, a semicircle, because it's bigger, it's like, it is 180, so we're still going to use three letters. So I'm going to make some other point here. I'm going to make some point here, E. Okay, so my semicircle is AEB is equal to 180 degrees. Again, we use three letters. We're never going to use the letter, we're never going to use the center of the circle. Never, ever, ever to name an arc. All right, here's something so easy. It's called arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. And it's like, wah, 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 wah. But let's first look, okay? So we're going to first, we know the measure of the major arc is equal to these two little segments. Okay, so I'm going to fill in some information. What if I said that the arc AB was 100 and the arc BC was 120? If I wanted to know arc ABC, remember it goes in that order, arc ABC is here, ABC, I'm just going to add those two together because 100 plus 120 is equal to 220. So the measure of the arc ABC is 220 degrees. You just add the two arcs together. Two arcs are congruent if they have the same measure and they are arcs on the same circle. So if you can see here, this central angle is 80 degrees. That makes this arc 80 degrees. This central angle is 80 degrees. That makes this arc 80 degrees. Okay. Also note that that CF is the diameter. So that makes CDF or CEF a semicircle. So the blue line that I just drew is 180 degrees. Well, if I have 80 here and 80 there, right? If we know that this whole thing is 180, we can just subtract the two congruent arcs, right? Because we know that they're equal to each other. So 180 minus 160 gives me 20. So that means this is 20 degrees here. Probably should change the color because I don't want you to be confused with the semicircle. So this is 20 degrees up here. Okay. So congruent arcs, if we were to name those two congruent arcs, we would just simply say arc DC is congruent to arc EF. Like that. All right, so now let's look at an example, okay? This gets a little crazy. We're gonna have to do some addition and maybe some subtraction. I don't know, let's check it out. So number one says the measure of arc AC. AC is in red here, okay? So that's inventors plus musicians, so 29 plus 108 gives me 137 degrees. Beautiful. I'm going to change colors, just try to keep this together, okay? So now it looks like this is going to be a major arc for number two, the measure of major arc ACD, or it could be a semicircle. Let's check it out. So since it goes from A to C first, I have to do that when I'm tracing my circle legs. So I'm not going to go this way, no. I'm going to go A to C to D. Now I'm going to add up 29 plus 108 plus 83. Okay, when I add those together, I get 220 degrees. Oh, excuse me, okay, so that was inventor, musician, and athlete. All right, next, number three, I have another major arc or a semicircle, ADC. Now I'm going to go the other way because D is the second letter, so I have to go this way, A, D, C. So now I'm going to take actor plus other plus athletes. So 79 plus 61 plus 83 is 223 degrees. All right, last one is EBD. EBD. So let's use orange. Okay, so if I start at E and I have to go to B first, that means I'm going to go to the left all the way around to D. So it's really like the whole circle minus the other. Okay, so I could take 360 minus 61 here, and that will give me the answer. And then I don't have to add up all those numbers. 360 minus 61 gives me 299 degrees. That's not terrible, but that's using the addition of the arc measures, okay? Okay, this practice problem was originally designed to be used with a protractor in class, but since we are not, we're going to skip it. Okay, so now we're going to use these images to identify what parts we have, okay? And I say images, I really mean, not this one. Let's get rid of this. This is going away. Oh, how do I get rid of it? Okay. Let's move this one up. This is the one we're going to use, this figure right here. And let's like fill out everything we know. Okay, first off, we see these hash marks here. I see this hash mark. Oops. And this hash mark. That means those two chords are congruent. Or those two arcs are congruent. I'm sorry, it's not a chord. Arc. All right, this one's 140, and this one's 60. So that means This here is 140. And this here is 60 degrees because that's how central angles work. And so if I take those two together, that gives me 200. 360 minus 200 is 160. I need to split that between my two congruent arcs. Divided by 2, I get 80. So that means this is 80 degrees and this is 80 degrees. All right, now, using that figure, we're going to name a major arc. It just says a major arc. So there might be more than one, minor arc. There might be more than one. So I have it BC is minor, CD is minor, AB is minor, and AD is a minor arc. Remember, a minor arc is less than 180 degrees. Next, we're going to name major arcs. Now, I only have two, but there is more than one, of course. So the major arc BCA, right? If we go BCA, that's pretty major. And then we can do the major arc ABC. That's another one. You only need one, really, right? So if it's ABC, that means we go A to B to C. Okay. Now remember when you see this little m, that means the measure. I'm looking for a number in degrees, the measure of the arc BC. Well, we figured that out to start, so this is going to be easy. That's 80 degrees. The measure of the minor arc AB is 140 degrees. The measure of the angle, remember this is angle of AED. If I trace that with my pencil, AED, that's in here, right? So if the arc is 80 degrees, that means this is 80 degrees. Central angles are like a mirror, okay? So this is 80 degrees. And then I have this major arc BDA. BDA. So let's change colors here. D is my second letter, so I have to hit D before I hit A. So B, D, A. So it's the whole circle minus 140. So 360 minus 140 gives me 220. So the measure of the major arc, BDA, is 220 degrees. Okay, that is what it is about arc measures, okay? So that isn't terribly difficult. Remember, central angles, whatever is in here, is going to project on the arc that angle intersects of the circle. All right, let's talk about 10.3, applying properties of chords. First, we're going to identify what we got going on here. Right, this blue line, what's this blue line called? A diameter. What's this blue line called? It's called a chord. All right. Something else I want to point out, the diameter splits a circle into two semicircles. Right? The chord splits a circle into a minor arc and a major arc. Oops. Okay, once we can identify that, you should be able to identify that. We're moving on. All right, here's another theorem, 10.3. In the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if you see, right, so these arcs, this is saying arc AB is congruent to arc BC if and only if AB, the chord AB, is congruent to the chord CB. You could have changed the order of those letters, that doesn't really matter. But that is a fact, okay? So that means that these arcs are congruent as well. All right, theorem 10.4, if one chord is perpendicular bisector of another chord, then the first chord is the diameter, okay? So if one chord, here's my one chord, is perpendicular, see how we have that right angle in here, to another, right, we get this right angle, that means that this JK was my diameter. So JK is the diameter. Let's look at another theorem. Theorem 10.5 says if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So the diameter, remember, is right here, this line that cuts through the center. So when it bisects this, so we know, because it tells us DE is congruent to EF, and that means chord DG is congruent to chord FG or GF, doesn't matter how you name it. Just make sure you put that notation on the top. It's really important that we put that like half curved line over top. All right, theorem 10.6, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so I need to have this. We need to have it that they are they're perpendicular. That segment is perpendicular. So AB is congruent to CD if and only if EF is congruent to EG. Okay. Let's look at some practice problems. All right, we're going to find X, okay? So if you notice that TR is the diameter and it intersects this chord and bisects it, we know that these arcs are congruent as well. So I can say 3x plus 24 is equal to 7x. Subtract 3x. 24 is equal to 4x. Divide by 4, and I get x is equal to 6. Fantastic. We did it. Okay, now it wants to find the measure of arc RS. RS is right here, so we're just going to plug in 6 here. So 7 times 6 is 42, so it's 42 degrees. All right, this next example, please make sure you copy this down and pay attention because it is on the test and I've seen so many people make silly mistakes. First off, here's our facts. Let's label all the facts. RU is 10. That's the diameter. Wow, that was not a straight line. Okay, but we know that whole thing is 10. Okay, and we know that Q is the center of the circle. So if the whole thing is 10, what's half of it? Okay, what's half of 10? So from here to here is 5. Okay, and then ST is 8. Right, so now we knew that RU is the diameter, so that means it bisects this. And if it's 8, the whole thing is 8, then each part is 4. Okay. Then what else do we know? We know that the measure of the angle SVU is 90 degrees. Where is that? SVU. So that means there's a right angle in here. Okay, so now we need to figure out some stuff. First off, let's see if we can answer any questions out the gate. SQ. Do we have the measure of SQ? Well, we know what QU is. It's 5. That's the radius. Well, SQ is a radius too. This is also 5. SV, well, we found that already. That's 4. VQ. I don't know about VQ or RV, but what I do know is I see a right triangle right here. You see this right triangle right here? I know we can do the Pythagorean Theorem. I know we know that 5 squared plus, let's just say this is x for now, x squared equals, oh, silly goose, not 5 squared, 4 squared. Sorry, guys. Leg squared plus leg squared equals hypotenuse squared. 4 squared is 16. plus x squared equals 25. I subtract 16, and I get x squared equals 9. Take the square root, and I get x is equal to plus or minus 3. In this case, it does not make sense to be negative 3, so x is positive 3. Okay, so now we know that this x is 3. We knew that the radius, so we know from Q to R is 5. 5 minus 3 is 2. That makes this part 2. You see that this whole thing was 5, because that's the radius. We subtracted the 3 and got that it's 2. And I know you're looking at it, you're like, well, it looks bigger than the 3, but don't let that play head games with you, okay? So now VQ is 3, and RV is 2. Ooh, that didn't show up very well. All right, hopefully, I mean, if you need to, rewatch it, and maybe pause it and see if you can do it, like, you know, erase your answers, play hide and seek with yourself, see if you understand it, and ask questions, please. If you do not understand, please ask questions. All right, your assignment tonight is number 51. So this is from section 10.2, and this is from section 10.3. I also listed a bunch of IXLs. I'm not going to assign them until the 7th, but they'll be due on the 15th. But if you want to, you know, if you're bored and you want to do some IXLs, you know, feel free, have at it. Have a good time. Other than that, then I will see you guys on Wednesday. Adios.